Hello everyone, this study is about modeling the relationships between handweight and speed in saturation flow of synchronized intersection. So as we all know, the operational efficiencies of synchronized intersections greatly impacts the performance of the whole transport system. The single timing is a vital component in the traffic design of synchronized intersection. And the discharging handweight, here is the timing handweight, is one of the crucial parameters in the signal timing design. The discharging handweight here is defined as the time interval between two successive vehicles in the same driving way passing the stoplight at a synchronized intersection. So the saturation flow rate is defined as the peak values of green discharge during the green time and is calculated by the equation here. The incorrect estimation of saturation flow rate will result in incorrect delay prediction and thus biased single timing setting. So in the literature, there are some studies about measuring the saturation flow rate. For example, some studies split the green time into 5 or 10 seconds and counting the vehicles passing the intersection during each period for saturation flow rates. And the highway capacity manual in USA, the value of saturated flow is calculated as a constant mean value of the time handweight of the vehicles passing synchronized intersection from the force vehicle. But there are some opposite viewpoints. In special cases, treating the discharge handweight as a constant would result in underestimation or overestimation of the saturation flow. There are also some literature modeling the relationship between speed and traffic volume. However, in summary, the existing research treats the discharge handweight as a constant and also investigating the variation of saturation handweight. Here is the time handweight. There is a real research about saturation handweight and speed modeling. So the background motivated us to quantitatively and empirically model the handweight speed relationship in saturated flow of synchronized intersection. This is aimed at optimal signal setting in intersections. We conducted this study based on observed traffic data in field survey. For the traffic survey, we have conducted experiments in 5 intersections in the Gold Coast city, which covers wide geographic situation. In these intersections, there are large traffic flow during peak hours, and the road widens and the flat gradients are standard. So we based on the survey can get the mean speed of vehicles passing each intersection and also the time of vehicle passing the intersection. The table shows the statistics of the surveyed intersection in terms of recording time, cycle number, and mean vehicle numbers per cycle. The 5 figures shows the intersections in the map. So we use the least squared method to model the handweight speed relationship, use connected data, and we compared the fitting degree of different proposed models. So in the model, the dependent variable is the time handweight, and the explanatory variable is the mean speed of vehicles passing the intersection. So we calculate the sum of the squares of regression, the sum of the difference between observed variable and the mean of observed variable. So we can, based on this results to get the R-square of proposed model. So here are the results. For the intersection of Macri and Bermuda, we use the data in cycle 20 and cycle 24 for the model estimation because they have the highest coordinates of it. So the results are shown in the two figures. The slope of the relationship between speed and hand weight is negative. That means the saturated hand weight was decreased when speed increased at this intersection. The saturated flow rate is the inverse of saturated hand weight, so it will increase with the speed improvement as well. For the results in intersection of fairway doctor and narrowing board weight, the results are shown in the figures. The candidate scope of cycle 6 and 13 are next to one, implying that the hand will decrease with the mean space speed. As for the results in intersection of parking node doctor and orthogonal even, the fitting model in cycle 15, the R-square is 0.52 and the root mean square error is 0.39. In the fitting model for cycle 24, the R-square is 0.18 and the RMS is 0.502. We can observe that the hand will decrease also with the increase of mean space speed. So as for the results in interaction of crowd root and orthogonal even, we use the data in cycle 4. The R-square is 0.55 and the root mean square error is 0.82. The slope of the model is also negative, therefore the saturated hand weight will decrease when speed increases at this intersection. So based on the empirical investigation, we found that the hand weight is significantly related to the mean speed. The hand weight increase with decreased speed across the intersection. The empirically and quantitatively calibrated relationship between the speed and time hand weight in saturated flow of single light intersection can be used to calculate the saturated flow rate in the intersection with different discharging speed. Thanks.